So guys, welcome to our channel once again. In today's video, we have these 20 questions to answer on acid, base, and salts. So guys, here in this video, we are going to be focusing on the subtopic general characteristics and properties of these acid, base, and salts. So guys, ensure to stay till the end of this video. Also, if you feel you want to answer the question before provide the answer at any point in this video, you can always pause the video and try out the question and see if you can get the answer before provide the answer thereafter. So guys, we're going to start with the first question here. It says, the Arrhenius theory is based on the A, theory of molecular size, B, theory of atoms, C, theory of reaction, D, theory of ionization. So guys, the answer to this question is option D, and that's theory of ionization. The Arrhenius theory is actually based on the theory of ionization. Arrhenius in 1884 proposed the concept of acid and base based on the theory of ionization. So according to Arrhenius, the acids are the hydrogen-containing compounds which give hydrogen ions or protons on dissociation in water, and then a base is a hydroxyl-containing compound which gives hydroxyl ion on dissociation in water. So that's it for that question, guys. Let's quickly look at the next question, and that's question number 2. It says, one of the following is a method of preparing acid. So we have A, dissolving an acid anhydride in water, B, neutralization method, C, reaction with base, D, reaction with metal. So guys, the answer to this question is option A, and that's dissolving an acid anhydride in water. Acid can be prepared by dissolving an acid anhydride in water. So guys, an acid anhydride is a non-metal oxide which forms an acid when reacted with water. So that's a good way of preparing acid. So let's look at the next question, guys. Question number 3, it says, which of the aqueous solution with the pH values below will liberate hydrogen when it reacts with magnesium metal? So guys, looking at the options here, we have A 3.0, B 13.0, C 6.5, and D 7.0. So guys, the answer to this question will be option A. So the most acidic pH here is that of option A, and that's 3.0. That's the answer to this question because it's going to liberate hydrogen gas when it reacts with magnesium metal. So guys, that's it for that question. Let's look at the next question. Question number 4, it says, the following methods are suitable methods of preparing simple salts except A, neutralization, B, reaction of an acid with a metal, B, hydrogenation, D, double decomposition. So guys, the answer to this question is option C, and that's hydrogenation. So hydrogenation actually means to treat hydrogen. It's a chemical reaction between molecular hydrogen and another compound or element. So usually in the presence of a catalyst such as maybe a nickel, platinum, and so on. So guys, this is not a method suitable for preparing simple salts, and as such, it's the answer to this question. So let's look at the next question. Question number 5, it says, normal salts are formed when all the replaceable hydrogen ions in the acid have been A, ionized, B, partially replaced by a metal, C, mixed with simple salts, D, completely replaced by metallic ions. So guys, the answer to this question is option D. That's when all the replaceable hydrogen ions in the acid have been completely replaced by metallic ions. So let's consider the next question. Question number 6. It says, zinc oxide is said to be amphoteric because it A. forms a double salt, B. forms an acid salt, C. is an insoluble base, D. reacts with a base or an acid. So guys, the answer to this question here is option D. Zinc oxide is said to be amphoteric because it reacts with a base or an acid. So let's look at the next question. Question number 7. It says, the process of boiling animal fat or plant oils with a strong base is known as A. purification, B. neutralization, C. Haber process, D. saponification. So guys, the answer to this question is option D, and that's saponification. Saponification is the process of boiling animal fat or plant oil with a strong base such as sodium hydroxide or potassium hydroxide. So let's consider the next question. Question number 8. It says, sulfur trioxide is not directly dissolved in water in the industrial preparation of sulfuric acid by the contact process because A. acid is usually added to water and not water to acid. B. the reaction between sulfur trioxide and water is violently exothermic. C. sulfur trioxide does not dissolve readily in water. D. sulfur trioxide is an acidic gas. So guys, the answer to this question is option B, and that's the reaction between sulfur trioxide and water is violently exothermic. The reaction between sulfur trioxide and water is violently exothermic. So take note of that. Let's consider the next question. Question number 9. It says, nitrogen dioxide reacts with water vapor in the atmosphere to form A. nitric acid, B. nitrogen gas, C. nitric oxide, D. nitrous acid. So guys, the answer to this question is option A, and that's nitric acid. Nitrogen dioxide reacts with water vapor in the atmosphere to form nitric acid. So guys, if we want to show the equation of this reaction, we can simply have nitrogen dioxide plus water, 2 of this, and this will be so guys, that's it for that question. So let's wipe this off and then let's go ahead and check out the next question. And guys, that's question number 10 here. So guys, question number 10 says, which of the following process involves neutralization? A. liming of soil, B. sharing of sugar, C. gardening of oils, D. souring of milk. So guys, the answer to this question is option A, and that's liming of soil. Actually, neutralization is a chemical reaction in which an acid and a base reacts to form a salt and water. So liming of soil is a process that involves the neutralization of acidic soil by adding lime, which is calcium carbonate, in this case a base. So this will neutralize the acid, forming salt and water. So guys, that's it for that question. Let's consider the next question. Question number 11. It says, dash is known as an alkali. A. a soluble hydroxide, B. an insoluble oxide, C. a soluble oxide, D. an insoluble hydroxide. So guys, the answer to this question is option A, and that's a soluble hydroxide. A soluble hydroxide is known as an alkali. So let's consider the next question. Question number 12, it says, all right, guys, we have a reaction here, and it's a reversible reaction here. It's a reaction between an acid here, which is the ethanoic acid, and a hydroxide ion here. And guys, here we have the products here, which is an ethanoate as well, and water. So guys, the question says, in the reaction above, ethanoate is the A, conjugate acid, B, base, C, acid, and D, conjugate base. So guys, the answer to this question is option D, and that's conjugate base. When an acid reacts with other compounds and it liberates a hydrogen ion, it forms a conjugate base. So guys, in this reaction, this ethanoic acid actually gives off a hydrogen ion, and that's a proton. So when it reacts in this manner and donates a proton, it forms a conjugate base. So guys, this ethanoate here on the product side is a conjugate base. So guys, that's it for that question. Let's consider the next question. Question number 13. It says, which of the following drying agents is not suitable for drying hydrogen sulfide? So option A, tetraphosphorus decalcide, B, calcium chloride, C, calcium oxide, and D, sulfuric acid or tetraoxosulfuric acid. So guys, the answer to this question is option D, and that's the tetraoxosulfuric acid. And that's because in the reaction between hydrogen sulfide and tetraoxosulfuric acid, the reaction is going to yield sulfur and water. So guys, if we want to check out the reaction, the equation of this reaction, let's zoom right in here. We'll have hydrogen sulfide reacting with tetraoxosulfuric acid, so this will yield water plus sulfur. So guys, in that case, sulfuric acid cannot be used as a drying agent for hydrogen sulfide. So we're going to go ahead and check out the next question. That's question number 14. It says, insoluble salts can be prepared by A, neutralization of alkali by an acid, B, the action of dilute acid on metal, C, direct combination of two electrons, D, the action of dilute acid on a trioxocarbonate 4. So guys, the answer to this question is option C, and that's direct combination of two elements. Insoluble salts can be prepared by direct combination of two elements. So the preparation of insoluble salts can either be by double decomposition or by combination of constituent elements. So let's consider the next question. Question number 15. It says, what happens when an acid reacts with a base? A, the acid and base neutralize each other to form salt and water. B, the acid releases oxygen gas. C, acid releases hydrogen gas. And D, the acid and base reacts to produce a metal oxide. So guys, in the reaction between an acid and a base, salt and water is the product formed. So option A is the correct answer to this question, and that's a neutralization reaction. So let's consider the next question, guys. Question number 16. It says, the basicity of ethanoic acid is A 2, B 4, C 3, D 1. So guys, I'd like you to pay attention to this question here and try to memorize this, and always remember the answer to this question. The basicity of ethanoic acid is 1. Guys, I've often seen this question here repeated, and you should pay attention to it and try to always remember that the basicity of ethanoic acid is 1. Actually, the basicity of a compound is the number of replaceable hydrogen in a molecule of that substance. So in the case of this ethanoic acid, there is just one replaceable hydrogen here, and that's what makes the basicity. So here, pay attention guys, especially to this compound, the ethanoic acid. The basicity is 1. So let's look at the next question. Question number 17. It says the number of hydroxonium ions produced by one molecule of an acid in aqueous solution is its A, acid strength, B, concentration, C, basicity, D, pH. So guys, the answer to this question is option C, and that's basicity. The number of hydroxonium ions produced by one molecule of an acid in aqueous solution is its basicity. So remember, we've already talked about this basicity, and remember that the basicity is the number of replaceable or ionizable hydroxonium ions or hydrogen ions that is present in one molecule of an acid in aqueous solution. So let's consider the next question. Question number 18. It says the contact process is used for the industrial production of A, hydrochloric acid, B, sodium hydroxide, C, calcium oxide, and D, sulfuric acid. So guys, the answer to this question is option D, and that's sulfuric acid. The contact process is used in the industrial production of sulfuric acid. So let's consider the next question. Question number 19. It says the acid that is used to remove rust is A, trioxonitrate 5, B, tetroxosulfate 6, C, hydrochloric, D, boric. So guys, the answer to this question is option C, and that's the hydrochloric acid. So they are highly corrosive, especially in concentrated form. So guys, HCl here is the answer to this question. So let's look at the next question and the last one for that. That's question number 20. It says, so here we have a diagram actually, and we have a reaction here. So this is an equation of a reaction, and from here we have to answer the question. The question here says, from the reaction above, which of the curves in the diagram represents the production of carbon dioxide as dilute hydrochloric acid is added? A, N, B, M, C, L, and D, P. So guys, without having to think of this so much, we have to understand that when reactions start occurring, the graph actually moves in such a manner that at initial stage, the concentration might be low, and then the concentration starts increasing with time. The concentration of the product actually starts increasing with time until it gets to a point where it flattens out. So guys, the option here that defines this is option A, and that's N in the graph. So guys, this is the correct answer to this question, because the reaction starts with producing just very little concentration of the products, and then the concentration of the products keeps increasing with time. until it gets to where it flattens out. That's where the concentration, that's where the reaction has fully occurred. So guys, that's it for this lesson. If you enjoyed this video, please give it a thumbs up. Don't forget to subscribe to our channel if you're not yet a subscriber. Also, if you have any question regarding this video, please drop your question on the comment section below and we're sure to give you a response. So guys, we'll also encourage you to join our channel membership. See you in the next video, guys. Thank you for watching this video.